In this video, I want to show you one of the best ways to make ethers, the Williamson ether synthesis. Let's jump right in. In the Williamson ether synthesis, we are making an ether, a carbon-oxygen-carbon. So I think the best way to make these, one of the best ways, is to take a good attacking alkoxide and let it backside attack something with a good leaving group on it. So X might be, what are some good leaving groups? Bromide or iodide or chloride or tosylate. Those are some options for X. And we'll backside attack, that leaving group leaves, and that'll make R oxygen R prime plus whatever my leaving group is. All right, so let's think about this just a little bit more. If I'm trying to make a negative oxygen, we can make those from alcohols. And we can take an alcohol, we can add sodium metal to it, or maybe we add sodium hydride. Those are both good enough bases. Sodium hydroxide is normally not good enough, but sodium is a good choice. I like to just grab sodium. We add some sodium, it pulls off the H plus to make O minus. And we also need something with a good leaving group. And we can make those too from alcohols. And you can go back and look at one of my previous alcohol reaction chapters. But we can take videos, but we can take an alcohol and turn it into a bromide if it's primary or secondary alcohol with like PBr3. And we can turn that into a bromide. You can use SOCl2 for a chloride, phosphorus and iodine for an iodine, tosyl chloride and pyridine for a tosylate. But you can make a good leaving group out of alcohols pretty easily. So if you have an alcohol, let's just pick an example. Let's say I'm trying to make isopropyl methyl ether. So if I have these two things, let's think about how I might try to make this compound. Well, I could potentially make that be my O minus, isopropoxide, and I could have CH3 with a leaving group. Or I could maybe make this from, let's put the leaving group on the isopropyl. And my negative oxide, alkoxide, is this methyl one. So I look at these two and I see which one of these do I like better. Do I like this backside attack better? Or do I like this backside attack better? And we see that this one attacks something that's not very crowded on the backside, but this one has to get past these two methyl groups. It's much more crowded. I don't think this is the best way to make it. I like this way better. So let's say we had to make this from an alcohol. Well, I can make this from that alcohol with sodium. That would make the alkoxide. And I can make this from methyl alcohol, methanol. And let's see, I could add PBr3 and turn that into a bromide. That backside attack would happen and I can make my final product, the Williamson ether synthesis. I hope that makes sense. Try to make it where you're attacking something that's not very crowded, and you can make an O minus from an alcohol and sodium, and just make sure the other group has a good leaving group on it. I hope that helps. So subscribe to the channel and watch more of my organic chemistry videos so I can help you be successful.